Service entrance conductors installed underground must be in a raceway approved for the purpose. The correct answer is liquid-tight flexible non-metallic conduit, or LFNC. National Electrical Code Section 230.40/16 specifies requirements for service entrance conductors. It states that service entrance conductors installed underground shall be in a raceway approved for the purpose. LFNC is an approved raceway. Flexible metal conduit, or FMC, is generally not approved for direct burial or use in wet locations unless specifically listed for such applications. Non-metallic sheathed cable, such as NMB cable, is not permitted for underground service entrance conductors. Liquid-type flexible metal conduit, or LFMC, is permitted for underground service entrance conductors but is not the most appropriate choice when LFNC is also an option, especially considering cost and corrosion resistance. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements in location. It is important to use appropriate wiring methods and materials for electrical installations to ensure safety and compliance with regulations. Ignoring code requirements can lead to electrical hazards, equipment failure, and potential safety risks. Selecting the correct type of conduit for underground service entrance conductors is critical for protecting the conductors from physical damage, moisture, and other environmental factors. LFNC is specifically designed for underground use and provides excellent protection against these elements. When installing underground service entrance conductors, carefully follow all applicable codes and standards. This includes proper burial depth, backfilling procedures, and support requirements for the raceway. Ensure that the raceway is properly sealed to prevent moisture from entering and causing corrosion or other damage to the conductors. Consider local environmental conditions such as soil type, moisture levels, and temperature variations when selecting the appropriate type of raceway and installation methods. These factors can affect the long-term performance and reliability of the electrical system. Before starting any electrical work, always disconnect the power supply to ensure safety. Use appropriate personal protective equipment, such as gloves and eye protection, to prevent injury. If unsure about any aspect of the installation, consult with a qualified electrician. Understanding the requirements for service entrance conductors is essential for anyone involved in electrical work, including electricians, contractors, and homeowners. By following the NEC and other applicable codes, it is possible to ensure the safety and reliability of electrical installations. It is also very important to know that codes and standards can vary depending on the local jurisdiction. Always check with the local authorities to determine the specific requirements and area. This can help avoid costly mistakes and ensure that electrical work complies with all applicable regulations. Regularly inspect electrical systems to identify and address any potential problems before they become safety hazards. This includes checking for damaged or corroded wiring, loose connections, and other signs of wear and tear. By taking proactive steps to maintain electrical systems, it is possible to prevent accidents and ensure the safety of occupants. When working with electrical systems, always exercise caution and follow safe work practices. This includes using appropriate tools and equipment, following lockout/tagout procedures, and avoiding contact with live electrical parts. Safety should always be the top priority when working with electricity. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC to ensure compliance and safety. In addition to the NEC, there may be other applicable codes and standards that govern electrical work in location. These may include local building codes, fire codes, and other regulations. Check with the local authorities to determine the specific requirements. Electrical inspections are typically required for new installations and renovations to ensure that the work complies with applicable codes and standards. Schedule an inspection with the local authorities before energizing the electrical system. This can help identify any potential problems and ensure that the work is safe and compliant. If planning to do any electrical work, it is essential to have a basic understanding of electrical theory and safe work practices. Take a course or workshop to learn about electrical principles, wiring methods, and safety procedures. This can help avoid mistakes and ensure that electrical work is done safely and correctly. Always use properly rated components and materials for electrical installations. This includes conductors, raceways, fittings, and other equipment. Using undersized or improperly rated components can lead to overheating, equipment failure, and potential safety hazards. When working with electrical circuits, it is important to understand the concepts of voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of current. Ohm's law states that voltage is equal to current multiplied by resistance. This fundamental law is used to calculate electrical parameters in circuits. Electrical circuits can be either series or parallel. In a series circuit, the components are connected end to end, and the current is the same through all components. In a parallel circuit, the components are connected side by side, and the voltage is the same across all components. Understanding the characteristics of series and parallel circuits is important for troubleshooting and designing electrical systems. Electrical power is the rate at which electrical energy is transferred. It is calculated by multiplying voltage by current. The unit of power is the watt. Electrical energy is the ability to do work. It is calculated by multiplying power by time. The unit of energy is the kilowatt-hour. Electrical safety is the most important consideration when working with electricity. Always follow safe work practices and use appropriate personal protective equipment to prevent injury. If unsure about any aspect of electrical work, consult with a qualified electrician. Understanding the principles of electricity and electrical safety is essential for anyone involved in electrical work, including electricians, contractors, and homeowners. By following safe work practices and complying with applicable codes and standards, it is possible to ensure the safety and reliability of electrical systems. Underground installations require careful consideration of soil conditions, moisture levels, and potential for physical damage. Using LF&C provides a robust and code-compliant solution for protecting service entrance conductors. Remember to consult with local electrical inspectors to ensure full compliance with all applicable regulations.